Hello everyone and welcome to Beginner's Code. In this episode we are going to take a further look into object-oriented programming to see how we can manipulate our classes to give more information upon instantiation. Okay, so the first thing that we're going to do is, at the end of last lesson we had a little look at adding some class attributes. And now we're going to see how we can actually use these class attributes with some class methods. So if I simply create a class, and this is just going to replicate a person. So what we can do is just have a number, and this will just be how many times this class of person has been instantiated, so how many different types of people we have. So now we can create our constructor method. So when we initialize our person, we need to have some attributes. So for this, we're going to give it a name. So we need self and name. If we wanted to give the person a height, a weight, an age, then we can. However, for now, we only need to do self.name. So now we can actually assign self.name to the name that was passed in. So self.name is equal to name. And now we're going to do something slightly different. So we're going to use the person name, so this person here, whatever we have called this class. So person, and then after we want to add to this number. So we actually want to, every time we create a class, we want to change this number by adding 1 to it. So what we want to do is just create a method, or the name of a method that we will actually be creating in a second. So what we're going to do is just have add underscore person and open and close parentheses. So every time this has been instantiated, every time there is a new object created, we are calling this method. And this method will be made in a second, and it will become a little bit more clearer. So now we want to have two methods. The first will just return how many people we've got, and the second will add to it. Now, because these methods we don't technically need to use outside of it, what we can do is just add a class method. And this just means that it doesn't actually need to be instantiated. So we can access this method without needing a object created of it. So def underscore number of people, and this will now take a parameter of CLS, and this means that it is a class method as well as this. So this decorator and this attribute both mean that this method can only be accessed inside of this class. So it's only a class method, it's not single for each individual instance of it. So if I create two different instances of this class person, so say down here I did P1 is equal to person, and then P2 is equal to person, they will both have exactly the same number of people method. So when this is called, so if down here I did P1.number of people, and then P2.number of people, these two will both return exactly the same regardless of how many times it has been instantiated. And that's because it is a class method and it is attached to the class, not to each individual instance. So if I just get rid of these, and then inside of this class method, the first one, we want to just return this number up here. Now to access this number, we need to use CLS, and that will use the class attributes. So CLS.num. And now in the second method we want to use is still another class method. However, this time we want to add a person. So def add underscore person. This will also take CLS. And then what we want to do is just cls.num plus equals 1. So we're not returning anything, we're not actually getting anything from this. the CLS is just, this method here is just adding 1 to this number. If we want to retrieve it, then we need to do the number of people. So now we have our very brief class methods and our very brief class. What we can do is just create 2 different instances. So if I use P1 is equal to person, and then we'll say Chris, and then P2 is equal to person, and we'll say Alice. And then what we can do is just print person dot number of people. Now if I save this and head over to my terminal, and then I'll just close that down. So cd desktop, and then so now when I've run this file, we get the value of 2 back, and that's because we have 2 different instances created. Now, what is cool is because we have 2 different instances created, we don't actually need to reference either P1 or P2. We can reference the class as a whole and still access this method. So the main reason why we use class methods is because we don't need a specific object to run this off. We can just call the name of the class and then use the attributes. So if I then did print person dot add person, and then I then printed person dot number of people, and then if I saved it and ran this file, we now get 2 and then 3. Now we get none because we're not actually returning anything here. Nothing's actually coming back, so we just have none. But you'll see that 3 is now, you'll see that the third one is now 3. So we have actually accessed this number attribute up here, this class attribute, affected it by using a class method, and then returned it by using another class method. And that's all without even creating our own instance of the object. So another very, very useful thing about object-oriented programming is something called static methods. So like we've seen down here with the person dot, we can also print things out and actually have things being interactive in our class with static methods. Now, static methods also allow us to just use the base class without having an instance of it. So if I delete all of this, and now if I create a class and just call it hello, now we want to use another decorator. This time it will be a static method, and we will just create a method called greet, and this will take no parameters, and we will return hello. Now we can now just print hello.greet and call it, and now if I run this file, we get hello back. So one thing to note is we didn't need to pass in the self parameter. It's not needed when we use a static method, and that's because the self parameter is basically telling Python, or telling the compiler, that we need to have an instance of the object to reference. However, with static methods, we don't. A static method can be there just for an easy way to print something when an object has been created, or an easy way to get some kind of data out there when an object has been created. So static methods are very, very useful. They are they're very similar to class methods, but they both have massive benefits, especially when it comes to not needing an instance of the actual object. So again, we have just referenced the class name and then the .greet method. So the next thing we want to do is just have a little talk about special methods. So there are 3 main special methods that I'm going to speak to you about today. There are a lot more that you can go and find. There is a lot of documentation on them. The first is the double_string method. So we have seen already the double under init method. So there is the double under str, double under len, and double under del. And the init we've already spoken about, that's the initializer. The str basically allows us to output something, a string representation of the class. So we may have something, a class being created like a car, and every time the class has been created, we could have the string method of this car is a X model with X color and X miles. So this would basically output a string representation that we can easily find out some more information of each object. The length is something that we can specify, and we can say what we want the length to be. So for example, we could have, again with the car, we could have the actual length of the side, and we could use some maths to work out how the height and the length and the width and everything equates to the length being a specific size. Or we could have, say, a book, and we could have the length of the book in terms of pages. And then finally we have the double under del, and the del basically allows us to delete an instance of the object. So if we want to see these in action, what we'll do is we'll just create a new method, or a new class, and this will be a class for a pet. So now we want to use a init method. The first parameter will be self, then name, then coat, and then legs. And what we want to do is, the first thing that we actually want to happen is just a print statement to be outputted. So print your pet has arrived, because it gets delivered by Amazon these days. And then self.name is equal to name, self.coat is equal to coat, and then self.legs is equal to legs. So now we want to create a string method. So we'll use double under str double under, and then this will take the value of self so that we can reference each individual object or each individual instance that has been created. And what we want to do here is just return a f string, which will say self.name has a self.coat and self.legs legs. I'm just going to add coat into the end here. So it will say self.name has something coat and something legs. So now we have our string representation. We can now look at the length. And for this one, we may as well just work out the length being legs. This is solely because I don't know how to work out the length of a cat without knowing the rest of the information. So we'll just go with the legs just to make it easy. So len and then self. So double underscore len, double underscore, and then self inside the parameters. And we're just going to return self.legs. And then finally, we want the double under del. And then what we can do is just print, and we will say an f string that says goodbye, and then self.name. So now we have our class that has 4 different special methods that we don't really need to use that often. However, they might come very handy. So what we can now do is just create one instance of our pet. So p1 is equal to pet, and we will call the first one Snowy. And then we will say Snowy has a brown coat and has 4 legs. So now if I was to run this, you will hopefully get nothing back. Oh no, we get your pet has arrived because that's the instance of the pet being created, and then goodbye Snowy. And that's because now that we've had it created, it then gets deleted. So it's something, the del method can be run at the end regardless. However, if I just make this a return return, I wonder if it will do the same. No, so now that it's a return statement, it doesn't actually print out the thing. It just says your pet has arrived, and that's good because we have our first instance. So Snowy should now be our pet. So we have our first instance, and what we want to do is just access these different methods. So how do we do this? Well, we can't actually access double underscores because they are something that's known as private, and this is something that we will get onto a lot more in terms of private attributes and things like that, and this will be in a lesson soon down the line. So what we can do is we'll just print, and then the first thing we'll do is we'll print P1. And if I save this and run this, we'll just take a look at what happens. So we now have your pet has arrived, Snowy has a brown coat and 4 legs. So just printing P1, what we're doing is instead of printing out this data or printing out this data, we're actually getting a string representation that we can print. And this gives us a little bit of insight into how or what information has been passed in a much more human readable way than Snowy, brown and 4. Snowy has a brown coat and 4 legs makes a lot more sense. So now that we know how to access the double underscore string method, we'll try and access the length. So as we've seen before with the majority of other data types, if you haven't actually seen the episode on data types, I will leave it at the top so that you can have a little look. But we can actually check the length of the majority of data types. And that is just a simple len. So say len of word, we should get 4. Sorry, I need to print it, that's my bad. So if I print the len of word and run this, we get 4. So we can actually access the length attribute using a function in itself. So now if I was to just pass in P1 and run this, we now get 4 back. And that's because we are actually accessing this length attribute by using, or this length method by using this length function. And they are working together to return whatever we have specified to be returned. So finally, with the del method, we just want to delete. And if I was to print the del of P1, so this will delete our instance of it. So now if I run this, I don't actually think this can be printed. So now if I run this, we don't actually have the output. However, if I was to say print P1 after, we have an error that says P1 is not defined, and that's because we have deleted P1 and then we have tried to access P1 after. So this has been a very, very brief overview of a few more things like class methods, static methods, and just getting to understand some special methods. So next time that we actually go over some object-oriented programming, we're going to be taking a look at some inheritance, polymorphism, abstraction, and encapsulation. Now, these 4 are the 4 pillars of object-oriented programming, and it makes it a lot easier to model and replicate real-world objects that we sometimes might need to come across in terms of things like users for a website or something like that. Thank you for watching. Hopefully this has helped your understanding and given you a little more confidence with object-oriented programming. If you liked what we've been through and you want to learn more, please drop a like and subscribe to my channel to keep up to date. Stay tuned, as in my next video I will be looking at using pandas and Seaborn for data visualization. Thank you, and I'll see you next time.